Hi everyone and welcome. In this video, we'll walk through how we built a retrieval augmented generation pipeline for coding analysis and technical question answering using a powerful stack of tools such as LlamaIndex, Firecrawl, and Moorcheh. This setup supports hybrid data ingestions, which means we allow both structured documents as well as live web content. We use LlamaIndex for local document ingestion and Firecrawl to scrape clean markdown from websites, all of which is uploaded to Moorcheh, our vector database, for fast and accurate retrieval. We then use this setup to ask real coding questions, allowing us to retrieve function definitions, explanations, and coding snippets across documentations and websites in one place. As always, you can find all the code that we're using in this demo on the Moorcheh.ai examples GitHub page. So whether you're a developer, technical writer, or building tools, this demo shows how semantic search and RAG pipelines can turn coding knowledge into actionable answers. Let's get started.
For the show of our code, we've pasted it into this Google Colab. To start, we're going to install all of the necessary packages, and we'll be importing these packages as we'll be making use of them in this chatbot. So some notable packages include the LlamaIndex Moorcheh vector store, and as well as Firecrawl. Next, we'll be getting our Moorcheh API key and our Firecrawl API key, and this will be done from the environment variables from Colab. We'll also be setting our namespace name. And we'll also be setting the documents folder, which is the folder that will contain all of the documents that we'll be uploading into the namespace. We also have a list of URLs that we'll be scraping, and we'll be uploading their text into namespace as well as context. We also set the namespace type to text because it is a text-based namespace, but you can set it to vector if you would like to upload vector embeddings instead. And finally, we set the top k to be equal to 5, so we'll be returning the top 5 most relevant chunks into the LLM so that can answer questions. Next, we have the scraping and chunking function, and this will essentially scrape and chunk each URL that's listed in this list right here, and turn it into a readable list of dictionaries that will be uploaded to Moorcheh for semantic search. Then we're also going to read all of the documents in our documents folder, and we're going to combine this with the scraped URL document chunks, and we're going to be uploading every single chunk into the namespace. Here we also set the chunk size to 5,000 characters and the chunk overlap to 20 characters per chunk, but you can switch these to whichever meets your specifications. Next, we're going to initialize the Moorcheh vector store. So we're going to use the API key from Moorcheh, and we're also going to use the namespace names and namespace type. We're also going to set the vector dimensions to none because it's a text-based namespace and not a vector namespace. For vector namespaces, you would set it to the number that represents a vector dimension. We also set add sparse vectors to false, as we will not be using LlamaIndex's sparse embedding, but we'll be using Moorcheh's embedding instead. And we also set the batch size to be equal to 100. That's just for the vector store. We've also set up batch uploading for the documents into the namespace.
Now we can move on to the generate answer method. So here, as you can see, if we run the cell, we get prompted to ask, do you want to enter a query? If we write Y or yes, then we could get another prompt to please enter our query. If we enter a query, the query goes to the get generative answer SDK call, in which we use the AI model Anthropic Claude 3.7, and it returns our answer. In this case, our query is going to be about Moorcheh's website and the GitHub. So in this case, we're going to ask, how do you upload documents to a Moorcheh namespace? And as you can see, we have all the required information, including parameters, to upload documents to a Moorcheh namespace. Similarly, another question we can ask is, how do we create Moorcheh client? And as you can see, it also provides all the required information and API call information for creating Moorcheh client. So a RAG pipeline works really well in answering our queries.
So to wrap up, this RAG pipeline showcases how semantic search powered by Moorcheh, combined with Firecrawl for web scraping and LlamaIndex for document ingestion, can deliver accurate, context-aware answers to real coding questions. So I'd like to thank you for watching our demo, and we hope to see you using Moorcheh in the future. Thank you.